In between, I just want to say that I'm happy to note that you people are watching my videos with the whole length. And I hope you are enjoying these videos also, the material I'm putting as a lecture notes also. So again, I will like you that you just please like these videos, subscribe them, and for notification, just press the bell icon. And for the notes, you can go to the notification, and there I have the links for the notes given there, and you can get it from there. You can copy them, and I have the more examples. Actually, here I'm not able to do more than 2 examples because otherwise it takes a long time. But in notes, they are given many other examples, and you can just read the example. So best use of example is that you solve the problem yourself, and after watch the video, try to understand the material, and then practice it by solving the problem given the example. Then compare your solution with that one. Then in the exercise, there are given many problems, and you do the practice. For mathematics, very important that you can learn it by doing the practice, by solving problem. You can't learn it just by watching the videos. You can't learn it. You have to practice yourself by solving it, and again, that will help you to learn more. Again, if you have any question, you can just put in the comments, or if you have any comments, you can give me there. So this will help me to improve my lectures also, and give you more and nice material. I'm going to give the example, as I was mentioning also in the introduction. A glass of hot water whose initial temperature is 80 degrees centigrade is placed in a room where the temperature is 30 degrees centigrade, and after 1 minute, the temperature drops to 70 degrees centigrade. Number 1, we want to find what is the temperature after 3 minutes. Number 2, we want to find at what time the water cools down to the 40 degrees centigrade. Obviously, we are applying here the Newton's law of cooling. So this is the difference of the temperature of the body and the surrounding. And when d by dt is proportional to that one, so change the proportionality by k, and this is my differential equation. So in this differential equation, I need 2 conditions to find the solution of that. Number 1, I need Ts, temperature of surrounding. Now, the temperature which is changing, that's not the surrounding. The temperature here, it is being in a room where the temperature is 30 degrees centigrade. So we can say that our Ts, in the room temperature, that is the temperature of surrounding, our Ts is equal to 30 degree centigrade. And as I mentioned also before, when there are the word problems, you have to read it 3-4 times, so that you have to extract the data from the problem. If you don't understand each word, then you are not able to extract the data. So you have to read that in depth 1, 2, 3, 4 times, and then you pick up the data from there. Now we are having this one. Now next is we want to find the initial condition. We need to find the constant of integration. So then we need 2 conditions. Now initially, it's being told to us that this hot water whose initial temperature. Initial temperature mean, number 1, at T is equal to 0, the temperature of the body is 80 degrees centigrade. It's my initial condition. It's my initial condition, I see. We always say I is initial, C for condition. Now next is, we need one more condition to find K. So given after 1 minute, the temperature dropped to 70 degrees centigrade. Number 2, we're having T equal to 1, and the temperature is equal to 70 degree centigrade. This is my additional condition. My additional condition, as I told you, I have told you that we want to find K, and we need here for that one more condition, additional condition. Now my problem is completed. I have the differential equation, I have the initial condition, differential equation, I get my general solution. Initial condition, I get the constant, and additional condition, I get the K, and my solution is completely known, and I can just solve. Then I can just make the predictions which are being required in the question. So here I go and I solve this one. So we have given the solution already, and we use that one, and then we having here the solution of this one. We integrate this one dt over T minus Ts is equal to integral k dt. We solve it to get here T minus Ts is equal to C e to power kt over T is equal to Ts plus C e to power kt. This is my equation 1. This is my general solution. And general solution, I have the arbitrary constant, and I solve my arbitrary constant. I take the initial condition. My initial condition is number 1, at t equal to 0, value of t is equal to at t equal to 80. We bring it, initially initial temperature is 80 degrees centigrade. So we can have here, now I have to find my Ts first. My Ts is equal to 30. So I rewrite this one, and I can write here my general solution, and I just change my Ts, because T is equal to 30. So I replace my Ts by 30 degrees centigrade. This is my temperature surrounding, I change it, and my solution is T is equal to 30 plus C e to power kt. So this is my number 1. This does this one, and we general solution. Now I want to find C and K. To find C, I have T is equal to 0. My temperature is equal to 80. Substitute here C e to power 0 times K plus 30 is equal to 80. Simplify this one, I get here C is equal to 80 minus 30 is equal to 50. I substitute in my equation 1, my T is equal to 30 plus 50 e to power kt is my particular solution. Particular solution of my problem. Now I want to find my K. To find K, I use my other condition, that's T equal to 1, and the temperature dropped to 70 degrees centigrade after 1 minute. So this is my additional condition. I substitute this condition here in my equation. This is my equation 2. In my equation 2, I'll get here this equal to 30 plus 50 e to power k is equal to 70. I take 30 to the side, I get here 50 e to power k is equal to 70 minus 30 is equal to 40. I get here e to power k is equal to 40 or 50 is equal to 0.8. My k is equal to, I'll take ln of both the side, ln of 0.8, and the value of 0.8 I can write it here, that when I make the calculations, then I will get the value of this one is equal to minus 0.223. That's the value of ln of 8. So I get my solution. My solution is T is equal to 30 plus 50 e to power 0.223 T. This is my number 3. This was my particular solution, and this is my complete solution. Now with this one, I just want to apply and find the number 1 and number 2. Find number 1, number 2. I just make some place here, solve my problem. So I'm having here. So I take here number 1, solution for number 1. At what time the temperature, what is the temperature after 3 minutes? So I'm given T, I can give you the temperature. You give me the temperature, I give you time. You given me that I want to calculate the temperature of time 3 minutes. So I can get here my T is equal to 30 plus 50 e to power minus 0.223 into 3. T is equal to 3. I calculate this one, and I will get here the solution of this one will be equal to 55.6 degrees centigrade. And number 2 is that at what time the water cool down to the 50 degrees centigrade. So I want to find T. So I'm given capital T. So capital T, I want to find when it will be the temperature of the water will be 40 degrees centigrade. I put the value of T here. I get 30 plus 50 e to power minus 0.223 T is equal to 40. I simplify this one. I get here 50 e to power minus 0.223 T is equal to 40 minus 30 is equal to 10. So get e to power minus 0.223 T is equal to 10 over 5 is equal to 0.2. I take ln of both the side, 0.223 T is equal to ln of 2, and my T is equal to ln of 0.2 over minus 0.2233. I use my calculator. I can simply just find the solution of this one. That's equal to 7.2 minutes. So that's the idea. We have discussed that we are given the temperature. We can give the time. We can calculate the time. We given the time. We can find the temperature. I just revise this one. We need three quantities. We need Ts. We need initial time. We need additional time. So these three T's we need to find. So sometimes become difficult, and the students are being confused in this finding this. So we must be very careful. What is the surrounding time, surrounding temperature, what is the initial temperature, and what's the additional conditions we get. So here we can see that we are given the glass of hot water, and its temperature is 80 degrees centigrade. This is my initial condition. This is my, because we are given here initial time. We are given here initial time. So bring in a room. A room is a place. Room is surrounding, where the temperature is 30. The temperature is 30. We say this is my Ts. So my T0, we say it is 80. My Ts, we say this is 30 degrees centigrade. So then after 1 minute, so what's changing? Now we are this temperature will not change. That's why we say this is Ts, remain constant. It's not going to change. But here this is changing after 1 minute. After 1 minute, the temperature drops to 70 degrees centigrade. So it means changing. That's my T1. This is my additional condition. Is 70 degrees centigrade. So we want to calculate two things. First, what is the temperature after 3 minutes when T equal to 3? And what is the time? We want to find time. What time is cooled down to the 40 degrees centigrade? So as I mentioned that we take the Newton law of cooling. We apply this one. The dt by dt is equal to k times k minus T. As first of all, we find Ts. Our Ts is 30. So we can just change this one, and we can write here instead of Ts. We can rewrite this. We can write here dt by dt is equal to k into T minus 30. And we don't need to write here Ts. We can just change this one to 30 instead of Ts. That's more correct, more accurate. We put here 30. Then we just integrate. And then we have the additional condition. Two conditions we need. The initial condition T equal to 0. The temperature is 80 degrees centigrade. As additional condition after 1 minute, it is 70 degrees centigrade. T1 is equal to 70. We have the complete question. Differential equation, initial condition and additional condition. We integrate by using separation of variable method. We separate the variable, integrate it, simplify it to get T is equal to 30 plus C e to power k. It is my general solution. Now here I want to find C and K. For C, I use initial condition. For K, I use additional condition. We use the initial condition T equal to 0. Then T is equal to, at T equal to 0, T is 80. We substitute here T equal to 0. And here T is equal to 80. We calculate, we get 50. We put here 50. And we get here this, our particular solution is 30 plus 50 e to power kt. Then to find K, we use the second condition, the additional condition T equal to 1. The temperature is 70. We take T equal to 1, temperature is 70. We substitute in our here in this equation because we want to find here our K. So we find the value of K. This is equal to 50, 30 plus 50 per kt is 70. Take 30 other side, get 40. Divide by 50. We get here 40 over 80 is 0.5. Take ln of both the side. K is equal to ln of 0.8. And ln of 0.8 is minus 0.223. Substitute here K value of K. We get here T is equal to 30 plus 50. This is my complete solution. Now with having this solution with me, I can just put the value of time, I get the temperature, put temperature, I get time. So I have the two one. First I want to find the temperature when T is equal to 3 minutes. So I put the value of T, this is my 3 minutes, and solve it. We get the solution as 55.6 degree centigrade. So the temperature after 3 minutes will be 55.6. The second one is want to find the time when temperature is 40. So here given me the temperature is 40 degrees centigrade. Find the time for this one. So put here the value of T, capital T. We put here capital T is equal to 40. Solve it. We get the value of T is equal to 7.2 minutes. So this is how we can solve this problem. So as I said, it's take long time. So I'm not able to solve many examples. The examples are given in my notes. You can just go to the description The links is given, notes are given. Just you can open this one, read it. You get the soft copy of that one, save in your computer or print it. It's up to you. Thank you very much. Inshallah, we will continue next time with our next chapter that will be about higher order differential equations.